I don't need this too much once I start doing the slide. Only a couple of slides, so we'll keep it nice and short. Yes, I'm Eric, WA6HHQ. Wayne and 6KR and I started Elecraft. Oh, literally in my basement in Aptos back in 1998. I think I may have started working on some of it in '97. We had become friends through another ham radio club in the Bay Area. And I thought I would never start a ham radio company because how can you make enough money to live off of that and actually stay in business for more than a few years? We somehow figured out how to do that. I luckily had started some other businesses before this, so that helped a little bit. I understood things like cash flow and profit and also doing a good product. I'm pretty picky about what we do, and so is Wayne. So we've built a good team with us. So we've had, well, it looks like going over 25 years now. So it's sort of scary that it's still going that long, but we're still here. It made it through even COVID where you couldn't get parts. So that's not fun at all, as you can imagine. And came back out the other end of that, and mostly whole. But all of us, I think, felt that in the business. But we came back and we're doing new products. I'll talk about some of the new stuff coming out for the K4 here too. So what I'm going to do is keep just a couple of slides, and so I don't put anybody to sleep, especially after. Thank you again for the barbecue here, and I'll stay awake at least while I'm talking. So I didn't drink any coffee, so I won't go any faster than I usually talk, which is too fast in the first place. So I'm going to go through a couple of slides though and just give you a little update on what's going on. Some of you that were at PacificCon saw some of this. I do have some actual show and tell stuff though too to go along with this. It may not translate too well on the small web camera we're using for these guys, but and I can show more in the room afterwards.
We can maybe move the camera.
Yeah, it might come close to it. Yeah. Sometime we should talk about how to do that. I could bring in a little mixer, video mixer that feeds into like your laptop as another camera, and then it can capture the screen off the K4. I do that when I do like live streaming, like we did during COVID, for instance, for club meetings and stuff. I can sort of fade and do, have cameras in me. And
nice.
Stuff. A little tough to carry all that down here for this right now. Okay, so let me go to the first slide here to show you what we're up to. So current news, one of the most important things, those of you that have been with us a long time, especially coming out of COVID, we had really long lead times. I started taking orders for the K4 in 2019 at Dayton, and I didn't deliver the first one until 2022. Think about that. That's how long it took. Now there's both the delays in engineering because we weren't all online all the time there. Engineers got sick. Luckily, they all survived it, but we also couldn't get parts and all the fun things that prevent you from ramping up as fast as you want to. But we made it through it, and we sold enough product to stay in business. Have all our products, the ones before that got out. But now we're at the point where we've got, especially just for people right now, people always assume they're going to have to wait, 5 or 6 weeks for our products. And K4, all these are off the shelf, or within 1 to 2 weeks. If I get a surge of orders, for instance, it might delay a little bit. We have to build another batch. But K4s, K4Ds, 1,500 amplifiers, 500 amplifiers, Cat 500 goes with that. Are all shipping from stock along with a lot of our other products. KX2s, KX3s usually are within a week. KH1s we're caught up with. That one, we got the backlog down. We introduced it about a year ago at PacificCon, actually at PacificCon, so we introduced it that day. And I sold so many that I was already immediately backlogged for several months. And then, of course, as we started shipping them, the rate went up, and we had to fight against that as it ran away from us for a while, and then we caught up with it. So we're shipping those from stock also. For those of you who like to build stuff, we have a simple kit. It's not a solder kit, because this is pretty small surface mount stuff on the KH1 little handheld CW radio that we sell. But you can mechanically assemble it and you get a feel for where everything is. And if you like to modify stuff, that makes it a lot easier. We actually charge a little, at least for the international version of that, a little more for that, because it actually costs us more to do a kit now these days than assembled when it's modular, because we have to test all the boards anyway and align everything and then take it out of the fixtures, back it back up and do all that. But the good news is you can get stuff, impulse buy. And you never would think expensive radios like a K4 or an impulse buy, you'd be surprised. Some people don't even want to wait a week sometimes. And they go off and buy something. The money's burning a hole in your pockets. Like when you want to get a car and you've thought about it, go in the dealer and they say, oh, you can't have that for 3 months. You go to another dealer, right? Or you go to get another car. So that's one thing that's important for us was to get caught up on this. And I'm going to try to maintain that. I'm sure there'll be times I slip back when I get surges and stuff, but it's been pretty good. So we've got that up there. That's a very important point. Then a couple of things. For those, how many folks have K4s in the room here? We've got a few of you. Good. Hopefully a few more coming out of this. We do software updates on the K4, just like you do on your iPhone or Android phone or anything. You can literally go on the screen, say check for updates. It'll say here's the newest one. You can read the release notes, see what's going on, and you can download it. Hit a button and sit back and watch it download over the internet. And by the way, I'm hooked up right now. I've got a little RJ45 Ethernet connection in the back of the radio to a little small router that can act as an extender also, or as a access point, which I'm doing right now. So I basically have it. It has an Ethernet output in the back of the radio, so that's sort of cool too. So I'm actually connected to my home station right now, and you can't really see that in the screen at home. I apologize, but we can play with that a little bit. With people come up close to it, I'll show you how the radio works and stuff too. But the new software coming out, we've been adding a whole bunch of features. We improved the digital voice for the voice guys, voice operation, Vox operations, a whole bunch of other stuff. There's just a whole bunch of things for remote that were improved on, but also operational for everything in the radio. This is something that's been going on for about 6 months. It's one of these things we're just about to get it released. We release it to our field testers, and they find 10 more things they didn't tell us about that we have to either add or fix or do something. So, and up to a certain point, I have to come in and say, turn off the engineering. Let's get this out. So we pick a good point for that. We're actually at that right now. Where what we call beta 4 is what they're testing in our field test group right now. And getting that going, and that'll be hopefully out in the next week or two here, because they usually right now they're testing the latest little things we changed, as long as we didn't screw up everything else when we did that. And occasionally you do, but we're pretty good at this. We've got a pretty tight team working on it. It's not like a very large software team. So as a result, we're pretty well in sync. Matter of fact, my 2 key programmers, one, Paul Safran, he's very good at everything from C to real-time microcode, DSP code, you name it. He's working with Brandon, who also did remotehams.com, the free remote site. Brandon does all of our remote software, but also a lot of our server side software internal to the radio. The radio is a client server architecture inside also. It's a Linux-based operating system for the UI running on that using Qt, if you're familiar with that programming environment. And then that system is a traffic cop for all the stuff going out of in and out of the system. We've got multiple, I think 6 or 8 microprocessors inside the radio doing different functions, everything from scanning the front panel keyboard, handling all the real-time transactions for real-time CW, for instance. That's how you can get a quick break-in with a software-based system. Don't do that on a multitasking system. It gets a little crazy, especially for faster CW operators. But in any case, that's coming out the next couple of weeks here, so keep an eye open for that. A couple of things here. I'll be able to demo K4 to K4. I forgot my K40. You're going to have to get mad at me here. I had it at Pacificon. So those of you that were there, I think a few of you were certainly here at it. I had that live connected to my home station, and it works just like you see on the K4 here. Obviously, not as big or as expensive as a K4. So it's about 4 inches deep, exact same front panel. Everything you see here operates exactly the same. It has the same I/O on the back too. So you can hook up your headsets, of course, Ethernet, logging programs. You can talk over TCP/IP, Ethernet TCP/IP to it to have your logging program like N1MM or any other DX, hunting program hooked up to it. So for contesting, DXing, it's exactly like what would be on your desktop, except you're controlling the remote radio. It thinks you're talking to it here locally. It doesn't know the difference. Let's see. So I'm going to talk about how that works a little bit in a bit, but I want to also talk about some of the other stuff here. I was going to demo with PK4, but we ran out of time to get everything set up for that. That's our software app that we're developing, though. That had to get slowed down recently. We have one engineer that left us recently, so we're in the process of getting that taken over at one of the other engineers in the group to finish it off. It's actually functional on transmit receive. I've been using it to workstations, but we're not happy with all the UI yet. There's the usual glitches you get on a program as you bring it close to market. Next thing, the HDR stuff. Most people say, when's that going to come out? And I would always say, end of the summer, this next spring. It always felt like it kept getting pushed off. So what I'm happy to say, that the guys at home are going to have a hard time seeing this, but this is actually not vaporware. This is a HD add-on board. It's real. This is actually more than one working in the lab right now. And we're going through the final software. We just brought up some of the frequency control stuff here actually this week for it, that on this latest version of the board. This has the exact same front-end superhead architecture we had in the K3 and K3S. And the benefit from what we learned from that, we actually been able to improve a little bit of the dynamic range, even for third order, I think, beyond what we had on that radio. And so what the big difference is, of course, is what this provides over a K4 direct sampling receiver. in the dynamic range department is primarily in the blocking dynamic range. When you've got a single signal, super strong, say on field day, where you've got people operating on 20-meter sideband, 20-meter CW, FT8, or whatever modes people are operating in. And the antennas are way closer than they should be to each other. They're not properly isolated. And if you do a proper setup, the K4 is happy as can be. But of course, neighbors are not far enough away all the time, 160 meters, things like that. So something like this buys you anywhere from 10 to 15 dB more blocking dynamic range in that area. And the K4 is no slouch. It's up close to 130 dB of blocking dynamic range. But getting up to 140, that buys you a bit more. And that basically requires a little bit of front end filtering and going into an IF. And then the back end is exactly the same as a K4 is. In other words, you're controlling it the same. You turn it on and off like a noise blanker. So you turn it on when you need it, turn it back off afterwards. It's pretty transparent that way, which is nice. So the whole idea is to make it easy to use. But those times where you've got that extreme case, and that happens to all of us. So certainly once in a while you're going to want to use it, but you're not going to leave it turned on all the time usually. So that's what this guy looks like. I can show you more afterwards and explain the circuits and stuff. I'll circle back to this in a little bit and talk about the block diagram. I know, John, you asked about this earlier, so you can get a feel for what it really looks like. Okay, other key thing, the 3D2Z guys. Anybody work them yet on Rotima? You probably talked to a K3 or a K4. I'm not sure which one. If it was a K4, they're operating it remotely with young kids. And I shouldn't say kids because young, our business is like 40 years old, probably, right? But we've got younger people coming in remote as remote de-expedition operators. I'm not doing it, but Greg Marco and his team down there are doing that. They got that in one of his new version of his remote inbox designs. And a couple of K3s that set up that way, I think, with the remote rig boxes doing the same thing, and K3 zeros and things like that are controlling. Or actually, I think they may even be using remote hams. I'm not positive, but they got that set up too. By the way, K4 works over remote hams also. It doesn't have the pan adapter integrated. Brandon's been working too much for us the last 10 years, but it theoretically could do that too, but it does full radio control over his stuff too. Anyway, 3D2 stuff. They've been getting that working. And I got a few late night phone calls because they forget what time it is here when they have problems. They've got Skylink and telephone over Wi-Fi, so you can call Greg on his phone or text with him. So text usually works better because we're not awake at the same times. But they had a few scares. They had a power surge or something, and they had to recycle the radios, and the remote didn't want to talk. The radio didn't want to talk to the router. Didn't want to give it an IP address. And then finally, one of my tech guys said, "Hey, did you bring a backup router?" And he goes, "Oh yeah." And they pulled that out and magically started working again. So something happened with that. So that's the quick current news on stuff. At this point, what I like to do is that just gives you a little feel for what we're doing here. Before I let you ask questions, I'd like to sort of describe the K4 HD in terms of what it does. Would be interested in that. I apologize, I don't have a block diagram I can put on the screen, so I'm going to sort of ask you to use your imagination. But I'm going to start, well, I'll give you an overview, and then I'll start at the antenna and just walk towards where it actually goes into the digital portion of the radio, which is exactly the same as a K4, and I'll describe a little bit how that works. But the key idea here is to add the superhet front end with optimized crystal filters, which, by the way, they're the toughest thing to get for third order intermodulation. That's the bottleneck in the system these days. We've gotten the front ends, the mixers, everything on that receive chain optimized to the point where the fellows, they get overloaded next are the crystal filters. They're hitting them that hard. And so we had to do some tricks in the K3 and K3S to get what we got with that, but even squeeze out more dB, we're doing a few more things on it right now. So we won't talk about how we do that, but it works pretty well. So what we're doing is really placing narrow filtering crystal filters at an IF. In this case, we have two IFs for two receivers. There's one on 8.215, same crystal filters as the K3 and K3S use. And then there's one approximately 9 megahertz. And actually, we're either going to do that design ourselves, like we did on some of our high performance crystal filters, or have them coming from Scott at INRAD. So he's done both of these for us in the past. That provides the protection for the analog to digital converter so it doesn't get overloaded by signals that are close to you geographically. They're super, super strong. We're talking in excess of 60 over 9, I mean, that kind of stuff, super loud signals. And they don't have to be on your obviously on your frequency, they're inside the passband of the crystal filter. Can't do much about that. But if they're 20 kilohertz away, you don't want them blanking a receiver, ideally, or even 10. So the crystal filters provide that level of protection on that kind of signal. So from a architectural standpoint, we start at the antenna. We basically, in the K4, outside of this board, already have front-end preamps that we can turn on at different stages. For those of you that have K4s, you know, we have preamp 1, preamp 2, preamp 3. 1 and 2 are changing the gain of a preamp after the bandpass filters in the radio. We come in from the antenna. If you're on transmitting on that same band, instead of using a separate antenna to receive, you're coming through our low-pass filters and then the bandpass filters that restrict the signals just to say 20 meters or 40 meters, whatever band you're on. Then that goes, there's a preamp after that we can turn on at 2 gain levels. So that's preamp 1, preamp 2. You go to preamp 3, maybe for the 6-meter moonbound skies where you're not worried about being blocked by guys typically. We have a MIC right where the antenna comes in. So that gain will cancel out any of the loss of your bandpass filters and all the stuff afterwards. And that's why you can get the maximum sensitivity when that's turned on preamp 3. The only weakness is you're not protected from the out of band signals as much. But fortunately, most cases you got good directional antennas or whatever you go, your weak signaling on you know, not just EME, but doing stuff on you know, sporadic E, things like that. 6, I've done all that stuff, and usually even if there's guys in the neighborhood on 6, my antenna, we're both pointed east, right? Usually there's no front to the side; it's not a big problem. So that's the preamp structure. You come in off the antenna. There's that preamp, the MMIC we call preamp 3. And then you go through the bandpass filters, of course, TR networks and things like that. With pin diode switched on all of our stuff. There's no relays clicking when you're going from transmit to receive. Those are have very high signal level immunity, obviously, because they have to handle the transmit signals. So the receive is easy for that stuff. Then we basically come into the bandpass filters, as I mentioned, and then you don't transmit to the bandpass filters, but we receive through them. And we go through the second preamp stage, which you're usually using most times. You're either preamp 1, preamp 2 on. Most lower bands, you don't need them at all, but especially once you get above 20 meters, or sometimes on 20 meters, it helps quite a bit. And then after that, in the K4, you're basically going directly into a 122.8 megahertz fire breathing, sample rate, a 16-bit A/D from analog devices, which doesn't cost $100. It costs a lot more than that. This is a very expensive little chip. And in terms of small size versus dollars, it's one of the bigger expenses. It's certainly the biggest, most expensive chip in the radio. That is sampling basically, if you think about it, those of you that know about Nyquist's sampling theory and stuff, we're good for about the bottom, DC almost up through 6 meters, roughly half the sampling frequency there, a little bit below that. So we can filter that off for aliasing and stuff. And so you can say in theory, you could get the whole band. That's a lot of stuff to digest though, and process and display and do with. So what we do is we immediately take that data. It goes to a chip right next to it, which is a pretty dense Altera, now Intel, field programmable gate array. And its purpose in life is to do several things. One is to take the data, say I'm just on one receive path right now. It takes that data coming in and digitally down converts it. Which you get more dynamic range out of it too, because we're undersampling at that point, or throwing away samples, excuse me. And what that does is it basically lowers your noise floor in the radio, get more dynamic range, and less bandwidth going through the system. We actually take it all the way down for the what you would call audio paths for filtering. It's not really audio, but it's at 48 kilohertz. That goes into the digital signal processing chips, which then do more filtering, demodulation, noise reduction, noise blanking, all that's done in the digital signal processor. It's an analog devices, ADSP2189 or 789, I think it is. I lose track of my last 2 digits on those, which one we have a couple of different ones we use in our small radio. And out the other end comes audio. What's nice is that FPGA isn't being taxed by just doing one of those. It generates, even on one analog to digital converter, 2 different receiver streams. And you can think of it as having a digital local oscillator for a VFO for each of those, converting it down to this 48 kilohertz sampling rate, and it's centered on whatever frequency range you want at that effective bandwidth. And it has a third, so we have 2 receiver paths. That's why on a basic K4 on one antenna, you can listen to 2 signals on the band with that also. You don't have to have the K4D to do that on the same band. If you want 2 antennas on the same or different bands, at the same time on the 2 receivers, like diversity reception, or if you're listening with a different kind of antenna, or on a different band, waiting for it to open, maybe 6 meters. you can do that. And that's the K4D because now you have two antenna paths. You need one per analog to digital converter. Yes, Russ.
So these two paths, you can put them in there so that they optimize between the two paths. The radio will select which one is the strongest.
Actually, okay, Russ is asking in the case of having two digital down converters with two antenna paths, so two A to D converters, that's the K4D. You can have two different antennas. So you can say one's your main transmit receive antenna, the other one might be, say your pick a band, whatever you want. So for diversity reception, what we do is we feed one receiver each ear, and let your brain pick which one you like. And that's interesting. Listen to a round table on 40 meters sometimes on one of those. You think you know where everybody is. Of course, they keep moving around on you as the phase changes a little bit. But it is true, though, in the contests and DX, and you have stuff when the bands are just opening, they're fading out. But how many people have used diversity in there? So you know what I'm sure you'll keep using it, right? Once you do, because typically if you have antennas at different heights, orientations, the number of combinations of different placement, the fading, saying the band's opening or closing or any other, one guy goes below the noise, odds are most of the time the other one's going to be above it. And they don't move in sync always. There's different arrival angles, there's different, incredible amount of variables. But your brain's amazingly good at that. Once you train it, you get hooked on that. It's really nice.
And this is all done at 48 kc.
That's done at 48. That's the final rate where it's going down towards what you want to call it audio is at 48 kc. The antennas are coming in, of course, at RF, every down sample. We're not doing phase steering with it. This is just coming in and basically demodulating two receivers. They are in phase. In other words, they're locked to each other. They're off the same master clock, so they're not going to be drifting around on you. It's stable that way. But getting back to it, so with one A to D, you can listen on two frequencies, like in a pile-up. You can listen to the pile-up and you can listen to the DX station. On a K4, that's no problem. And of course, on a K4D on one of the receiver chips, you can do that too. But with the K4D, you can also use the two antenna trick, like we're talking about, or listen to another band, waiting for it to open at the same time. The other key thing is we have one more channel in that. That's for the pan adapter. So we want that wide, right? So 400 kilohertz bandwidth comes out of that. Interestingly, we run that directly into a PIC microprocessor on our digital down converter card, which, by the way, is one of these little guys. I can show it to you afterwards, but it's quite small. It's one of the most expensive cards in the system, though. That comes out and goes to a PIC processor that does the actual FFT, fast Fourier transform, that does basically the spectral display, spits that out as basically data points. We call it dB per bin data. It says amplitude at this point, you have this many points in the scan across that range. Let's call it a couple thousand or whatever is reasonable. And then that goes to our main processor that does the graphic display and displays it. That's how you see it. That's all happening off a 180D converter. You can see basically that one band on the pan adapter, but we can show you two bands because we're getting the data at such a high rate. We can ping pong that between two different frequencies. And you do pay a little bit of penalty. It's a little slower update rate on the pan adapter. And if you compare a K4 to K4D, when you're listening to two different bands or portions in the same band with the pan adapter, not listening, but displaying, way apart from each other, it'll come back and go a little bit slower, especially if we're on different bands, because that's moving quite a bit at that point. Whereas with the K4D, you have two separate pan adapter paths, and it goes a little faster. Operationally, you don't even know how it got there. You just know it goes a little faster, but it doesn't require you to do anything different. So far, we're going down that chain. So far, I'm just doing the digital radio. If you think about it, this is all the digital radio. What's different about the K4D add-on board when you turn it on? Well, before we go to the A to D converter, we add this additional superhet front end, which in essence is putting a crystal filter in front of the A to D. In the simplest case, you could have a 500 hertz filter, you could have a 2.7 kilohertz filter. To be honest, you don't need much more than a sideband bandwidth filter because, again, for blocking, which is the main thing that helps you on, it's going to basically, if the guy's close enough to be maybe on the tail edges of that filter, on a wider filter, or just not quite in it. If he's 2 or 3 or 5 kilohertz away, and they're at the we're trying to get this 140 dB above your noise floor immunity. Not their phase noise so much, but their key clicks, their transmit IMD, even with pure signal, is going to be inside your passband of your crystal filter, no matter how narrow it is. It really doesn't matter. The back-end filtering is exactly the same DSP, same DS modulation. We go into another card, it's much simpler, and we wanted to keep those two wideband pen adapters working. So we keep the other two cards doing that, not using their audio at the moment, but we're basically doing that here when you turn this on. But then this goes to same digital down converter architecture, a third one that we put in there. So you've got three of those in a K4 HD versus two in a K4D and one in a K4, which explains why they get more expensive as you go up that path. But it gives you a nice feature. You can turn on and off quickly. So that's how it works. And so we're in the lab right now for real. This is a next generation version of it. I think I'll turn the board at least once. We always find mistakes, at least, these things, but that's going to go pretty quick. And actually, I just hired a new engineer also who's a 30-year RF designer. You don't find too many of these guys over in Monterey Bay, but he retired from one of the other high-tech companies in our area and had been doing RF there, California Eastern Labs, a few other places you may have heard of. So he's quite a sharp guy. He's got this project right now to finish up. So that's going to be fun. So that's sort of a quick quasi block time. Easier, obviously. I'm just sort of waving my arms and hoping you guys can picture what I'm talking about as I walk down that receiver chain. But it's really simple in concept. Implementation is a lot of subtle stuff. How do you keep the image on a mixer from overloading your crystal filters? That's an additional energy coming in. Well, you have to filter that out also. How do you properly impedance manage the crystals? We found the 9 megahertz crystals have a different design impedance than the 8.215 crystals. So we had to characterize that. Things like you don't do those right, your dynamic range degrades. All that stuff is, you get more distortion whenever that kind of stuff isn't matched properly. So a lot of it, you have to measure it, and no matter what they tell you in the specs, if you don't measure it, you really don't know what's going on. So we do all that stuff too. So that's the HD in a nutshell. Give you a
When do you think they'll release it?
by date, and I hope, if not earlier. I'd say earlier because people start laughing at me now because whenever I say that, I get in trouble. So I'm trying to be conservative right now. I honestly think it'll beat that, but probably it's more the software to be a delay on me. Usually, I always get surprised by how much work software takes. But what's good is all the back end stuff stays exactly the same. So we're not rewriting the whole architecture of the radio. It's really the command control of this circuitry here, and we've got that up and running right now. So I'm pretty optimistic on that. And I have some experienced guys working on it. They have worked on, these are some of the same people that did firmware for our synthesizers in the K3S, which use the same silicon graphics, which is now Skyworks, not silicon graphics, Silicon Labs, SI570, if any of you are familiar with the chips in that area. It's very, very nice oscillator chip. They actually felt they made it too good, and we want too many of them, so they can't get rid of us because I use them a lot, both on the K3Ss and now on these. So there's two of them on this stuff, the two receiver paths. So that's how we did that.
So
go ahead, questions.
Can you take a question?
And I'm ready for them.
Rick, NK7I wants to know how many H modules do you need in a K4 HD?
One. Just one. We say H modules. I mean, are you saying the HD boards? Is that?
Yeah, I think that's what he means.
Yeah, the HD board. It's probably hard for you guys to see it on screen here. Can you see it on the screen? If I walk up close, can you tell me where I'm getting bigger?
Hang on, let me take a look.
I can't see.
It's better. Yeah.
Okay, let me walk up closer.
Yeah,
you tell me when to
That's
stop.
good.
Okay. If you see there's crystal filters on both sides of the boards, those are identical receive paths for the two receive paths in the radio. You have to have a K4D to upgrade to an HD. If you're going to go from a K4, you're going to have to go to a K4D and then to an HD. You can't skip around that because we use pieces of each as you go there. But this board has, it's on the back side too, double-sided. It actually has some additional filtering. So it gives us a little bit sharper filtering in the front end going into this. In addition, and basically has the IF channel going down to 8 a mixer, a high performance switching mixer, using, I forgot the part number on it, FST21 something. I forget what it is. It's a real fast bus switch. So we can do that. And that's a very high dynamic range. We use this, the K3S. We actually have a better version of this mixer now that we designed for this. And of course the microprocessor to control some of the basic turning stuff on and on. Sounds simple, but there's a lot more to it. I think there's 6 or 8 layers on this board. So you get that, and you get the digital down converter with the A to D chip. And the big thing with the heat sink on it, I don't know if you guys can see that black blob on the webcam. You guys there, that's the field programmable gate array. That's the one that gets hot. The A to D gets warm, but that guy really gets hot because he's working hard.
Another question?
Yeah, go ahead.
Roberto K6KM wants to know when the K40 will be released. He says in Friedrichshafen, is end of fall.
Yeah.
Which year? Well, I made a mistake. Somebody caught me at that, and I hadn't, at that stage, this was a year or more than a year ago, I think, at Friedrichshafen. I thought I was going to have it at the fall here. We got a little delayed on it, but actually now it's moved quite quickly. I've got working stuff on the bench. One nice thing about the K40 is you can power it either off a 13.8 volt supply with APP connectors, but that seems a lot to carry around when you're going portable. So we built in, because we have an option for internal battery on that too, so you can go couch mobile and operate DX, while you're watching the Warrior game or something. So you can't miss that guy. So that's got a charge, USB-C port for charging the battery, but also can power the radio with a little 30 watt USB. And basically, we use the 15 volt voltage at 2 amps. And this thing draws, I think less than an amp typically. So when it's when it's a K40. To answer the question, I'm trying to get this thing to field chest right after Christmas, probably in the January timeframe. We're getting ready to order the batches, sheet metal, and all the boards. We've already done the basic. The only additional board to the radio beyond the standard front panel board is what you're seeing in this radio, the board, the display, pit buttons. It's the same thing. We literally come off the same line that does that portion of it. Has a chassis that's just a U-shaped chassis. And of course, more to it than that, but built-in speakers left and right. Of course, you can plug in an external speaker. You can plug in your paddle keys, all that stuff. Headset and mic in the front or back. It goes on. You look at the back of a K4, they look almost identical. The key work on it right now is a little more of the UI for it. Not a whole bunch, because I'll show you how I can connect. I mean, I'm connected to my house right now. If I want to disconnect, I push this little globe, which you guys at home can't see. Brings up my connection dialog. I just disconnected from my house. I was going to connect to Brandon, but guess where he happens to live? About an hour to the west of Reading right now. And he's on either on Skylink, or which is a little tough sometimes, or on a terrestrial 5 gigahertz ubiquity dish kind of network for us.
He's driving right now?
No, he lives up there. He moved up there during COVID with his family and built a place, and no noise. It's the quietest damn. I switched from my house to his house. The signals are weaker. The signal noises tend to be better. Always. I mean, he's on G5RV up there right now. He hasn't put anything up fancy, and he's just, it's an amazing spot. I can't connect to him right now. The link went down. He was worried about that because he had a big enough storm. He said that between the electrical noise and the general wind and everything else, the dishes are moving around. Everything's the water, of course. I don't know what 5 gigahertz it resonates with it as much as 2.4, but it is that some impact? Yeah, I'm sure it does. So. He wasn't, I can try him. I think it'll just time out, but I can go back to my station. My glasses off. Where am I? Actually, I'm already on it, so I can just hit connect. Now, I don't know if you can you hear noise. There's not much going on. I actually have it on 20 meters right now. It sounds like one of the data modes in there, FT8 was on. I think that's FT8 up in the top of the band there or something. But, and I can't see if my glasses off, so I can't tell what I'm on, but that's controlling my house right now. Yes, go ahead.
Eric, at Pacificon, you gave some enlightening commentary about the effect that FT8 is having on the wear and tear of radios and amplifiers.
Oh, yeah.
Maybe you could share that with the guys here. I found that fascinating.
Yeah, it's true for anything. And most of
it applies to the KPA 500 or 1500.
It applies to all of them. FT8 is, and you can talk to any amplifier manufacturer, they'll tell you as they've seen an increase of issues of people running FT8. The ones that really cause us problems are people who are pushing the envelope outside, usually the normal legal power limit. On the KPA 1500, we have those of you that don't know, we can log all failures. We know what frequency you're on. I can tell you we're on FT8. I can tell you we're running about 1900 watts, which is actually above where we're supposed to fault at. But FT8 cycles on and off. I'm just rounding off now, approximately every 15 seconds, right? Just think about that. Hot, cold, hot, cold, hot, cold, hot, cold. Yeah, I mean, yeah, you're going to mechanically, everything in the system gets stressed when you do that. And you find stuff that never caused a problem before. And we've done a lot of things to, we anticipated JT65 and things like that. So we did a lot of stuff that accommodates that. But I've seen cases, especially in the very, very early 1500s, where they cracked the solder on the PA transistors. That doesn't happen much in the newer stuff because we changed our process a long time ago on that, to the 1500.
Jumpers, feeding boards.
Those were changed to ones that are little loops.
Yeah.
And once you did that, that went away. We have an input and output board in the KPA 1500. It sandwiches the LD MOSFETs between the gate. They're basically a big flat package that is actually, think about it as just reflow soldered into a groove cut in a big thick piece, I think of 3/8 copper. That's the heat spreader, and then a big heat sink underneath it where the fan blows air across. And that's what's recommended by the manufacturers, but you have to do it right. And we have that process pretty well controlled now. But one thing we found we had to do is, one, you mentioned that there's these two boards, an input and output board that goes on each side of it. So you can, and you solder the flat tabs coming out of the power transistors, those flat devices, so they're coming in. And so you have the source and drain on one end and the gates on the other side. And we found that normal soldering for FT8 guys, especially, we caught this early on when it first was starting. It wasn't just FT8, some RTTY guys caught it too. We wanted to have more solder there, more than you would normally think. We literally have to have flood it to the level where you have almost a little bubble, and that can handle it. We haven't seen those crack at all.
Have you had any physical updates to the 1500, say in the last 18 months?
No. No. The question was, have we had any physical updates like this? Yeah, the loops were long before that. I forget how far back, but it was more than 18 months back, way early. And that's easy to put in. This is just, they were straight wires going between two boards that are mounted on this copper plate. And just you think with a different coefficient of expansion, you could get in trouble.
Nothing says that away physical.
No. You can literally take this, you can open the case and look on the bottom where the PA is. Everything's upside down there, heat sinks on top of it, and that's on the bottom. You'll see the two boards. We can help you talk to our tech, like Renee is one of my key techs on that.
I just want to find out if there's any mods.
No other mods right now.
In there.
No, but you can always, you always tell us your serial number. We'll tell you what we think might have changed. Usually if it's ever come back into us, it's already got everything up to date that ever happened in the past. Because I'll still get serial numbers in the teens, or 20s, you'd be surprised how long they sit out there and stuff. But when they come in, sometimes just because they want to have them upgraded, or there are other cases, something died or they did something themselves. Lightning gets, we can't protect you from yourself with leaving antennas on during the lightning. I can actually tell you where the bad storms are in the US by watching amplifiers come in. That's an expensive mistake to make. SO2R boxes that malfunction, that doesn't do a good job on anybody's radio or amplifier. It does weird stuff.
Do you have people on your staff that are watching the 1500 reflector?
Which reflector are you referring to? There's too many for us even to keep up with.
Oh, real one. No, this is a reflector on the KPA 1500. I signed up for 2-3 years
Yeah, it's
ago.
not, we don't run any of those reflectors. The only one we run is the Elecraft, the mailman at elecraft.com, or Elecraft at mailman.qth.net is the one we run. There, we do go across for K4, the groups.io K4 deal, and that's probably where the 1500 on groups.io is where you're thinking, where most of them moved from Yahoo to there. Occasionally we get over to look at the other ones, but I can't keep up with the smaller ones. It's just way too much. Usually if something's going on, we hear about it, though. It gets to us pretty quick. So it's got a natural way of showing up in customer support or somewhere if there's a problem or just a question. Yeah, people misinterpret things sometimes.
Well, on that reflector, a couple of days ago, a guy in Ohio pushing it on 6-meter FTA, and he whomped one of the transistors.
Sure.
And all of a sudden, instead of having 1500 watts, he's got 650.
That's, yeah, it's use common sense when you're doing that stuff. First of all, in FTA, you don't need to run above 1500 watts or even ideal. If you're going to run short contacts, like you're just really quick, you're going to make a few contacts and get off, fine. But if you're constantly calling CQ or trying to work a continual deal there, I would say back off your power a little bit. It helps. But the current amps that go out the door, it's less of a problem. But I'll never say never because I've learned amps we all have an amazing. I've blown up a lot of my own amps that I've had over the years, at tube types included, and I'm sure you have too, Russ. So all of us have made those mistakes.
So on 6 meters, I started like 800 1/4.
Yeah.
And by the time you made 5 or 6 contacts, it's down to like 775 or 750. I said heats up, the power goes down.
A little bit. That's not unusual. Yeah.
75 watts over a period of
Yeah,
15 minutes.
not at those, at the high power level, sure, you'll see a heat reduction, both, different loss and low pass filters, they're heating up too, don't forget.
Right.
And also the devices change a little bit in their gain and stuff, so
But the 10% loss in that period is
that's not unusual, no,
not unusual.
no. Especially when you're first using it, 'cause that's the biggest change usually. Yeah, that's what I was saying, yeah, the semiconductor guys get that one right away.
Yeah,
There's no free lunch there. Yeah, go ahead, I'm
another
sorry.
question, Kent N6WT wants to know on the KH1, when will the next firmware update come out for CW memory messages that can be entered in the KH1 units?
I have no idea on that. I apologize. So the question was, when are we doing something additional? We have memories right now, but we don't have something you can enter in the utility. I honestly don't know because I know Wayne, that's Wayne's personal firmware project. And he's actually doing some mechanicals for us right now on the K40. That's one of his other key skills is mechanical design. Most of the mechanical stuff you see was designed by Wayne on these products. And all the 3D printed stuff, like on the K40, I've got these flip out feet, which you cannot tell from really high quality, products you bought molded or anything. It's wonderful stuff. It's gotten to the same price range. You can literally, I can have a design and have, 500 pieces on the dock in the next 18 days. And so, but getting back to that, he's tied up doing some K30 stuff. We had some, the feet work great when you have the tilt feet out on the front of the K40. If you fold it up like it's flat on the shelf in front of you, it wants to fall forward because we didn't bring the feet far enough forward when they're folded up. When you're tilted back, your center of gravity was back, everything was perfect, right? But so he got that. It's real nice with 3D. You could make that change. And so he basically extended them out within about, I don't know, maybe eighth of an inch or so of the front edge of the bottom here. Now the ones that came flat. So when they're folded up flat, now they have full stability, which is nice. But he's doing things like that. When he gets back on that software, he'll start talking about it, but it usually takes multiple months before it happens. I don't even know if he's promised that.
Rick NK7I asks,
Hi, Rick.
do you expect any changes to the LP amp to improve cooling for the QRPers?
The best thing to do on a K4 or a K3 is do not run the 10 watt PA in FT8 at right before it switches to the high power PA. And by the way, there's only 18 10 watt K4s out there, and 4 of them are about 100 watt amplifiers. So I know out of the thousands we've sold. So don't ask me how I know that, but I actually was looking at the stats for somebody recently. But that said, I mean, you can still run low power, but I'd recommend if you're in data modes that you actually run just above where it switches over to using the KPA 4, the 100 watt amp, CP at 12, 13 watts. Then you're home free. Because usually we're only driving the PA even at full power with less than 5 watts. So it's and then that works out real well. Yeah.
So one thing that I'm totally satisfied.
Oh, it's always something. Yeah.
It's the noise reduction.
Well, yeah, and that's something that I thought I had a solution for back when we were first talking about doing this. Unfortunately, the author of that is quite elderly, and the code turned out to be unreadable. This is the best way of putting it. So we've got a project on that, but it's not something I can put a date on. I got lots of things in the hopper, but I just don't know when they're going to pop out because we're trying to juggle a lot of things. But we have to keep.
But it is in the.
Well, I think there's always things we can do. Actually, I have a few minor things that actually the current algorithm we're gonna do. I think fairly quickly because one of the things. Well, I won't talk about it here. So there's a few things we can improve better on it too. Yes.
Any updates? Again, Rick. Any updates on transverter ETA?
Oh, the 140, the dual band option. That's the last card you can fit in the radio. By the way, this card fits the HD. I've been holding up here. Fits in the front part here, and of course you add another card, the digital compartment for the A to D, the digital down converter. Behind that is where the 20 watt, 144 and 432 board goes. That's not even we have it designed on paper, but it's not, and I think it may be laid out too. I think I've got the layout. Actually, back during COVID, I bought a reel of PIC processors because I found them on DigiKey for a cheap price. So I know I've got a lot of microprocessors for it, so I'm not worried about that. Same thing for the ones used on this. Wish they were the same, but we needed different IO complements and a few other peripherals difference. But I'm not going to put a date on it, but that comes out after this is released and shipping. The HD modules are out there. Other questions here, elsewhere? I managed to keep you guys awake. Anybody snooze off?
price target for the HD upgrade?
It'll be probably right around $1,000 in that area. Plus or minus 100. I don't think it'll go above that unless somebody increases something. It's literally every week I get surprised on something on pricing. I mean, anybody of you guys, I'm sure we got a bunch of you in the industry, you know what it's like right now. We have tariffs come on, watch out, because right now, even if I buy things from a US company, say for heat sinks on the 1500 KPA4, guess where either the raw aluminum is coming from or the actual extruded parts are coming from. Even though I'm buying from a company in Livermore, they're coming from China. So, and it's not just China, obviously. So if we get huge, they're already paying 20% tariffs on a lot of that. So, but and I get those tariff things each month and says, you know, they don't even tell me which parts they're on from my contract manufacturer. I'm forcing them to now tell me at least which board they're on coming into me so I can allocate the tariff by product so I know what it's costing me. But it's tough. And don't let anybody think that everybody can absorb that. It doesn't work that way. Prices go up. That's actually part of what happened to us in COVID too. Of course, the whole chain took advantage of that too. Everybody raised their prices during that when you couldn't get parts. They never went back down to their original pricing. Yeah, everybody works.
Funny how that works.
Cars too.
Pretty soon people are gonna start pushing back. Just wait and see when it
Well,
starts.
we'll find. It's tough. I agree.
Finally-
I've been screaming for a long time, at least through an electronic parts standpoint, certainly. And we push back hard on our suppliers too. I mean, we work with them and we find ways to save money wherever we can. So it's a give and take or two.
That
Yeah, Russ.
K4 HD, if I own a K4D, I can just buy that.
Yeah, you can install it. Yeah.
Put it in my.
Yeah. Or if you don't feel comfortable doing that, it's basically these two boards, a number of cables. You'll see the little, I forget the nomenclature for these little guys here. Okay. Is that MCX? Yeah, these are MCXs. And we got the little snap-in ones. They're nice quality.
Yeah, they
are. They're not cheap, but yeah, we use those all. They're gold plate. We use them all over going into the DVC cards. I don't know if it shows on this one. It should. There's one right in the bottom that goes through a board. You pop into it. This might be an original one that was something different on it. Looks like.
Something wrong with that one. That's why you got it.
Yeah, this is not a working unit. That was just one to show you guys. I don't walk around with those in my pocket otherwise.
So once I get all the ports in my radio, is there much alignment, calibration required?
No, surprisingly not. There might be a little bit but we're going to pre-align all the RF stages and stuff where they are adjustable. When I look on this board, we've got a little bit of additional filtering. I see three trim caps in each of the receive filters on this. So
You'll probably tune those.
we tune everything up. So no, it'll be a drop-in for you. It's more mechanical. The toughest thing about mechanical, if you go look on our website in the digital compartment, whenever you want to put another digital down converter, so you go from a K4 to a K4D or and so on. How do you do that? Yeah, because you have to the industrial single board computer. It's a company called Aon. I think they were a spin-off originally from Dell. They're owned by Asus now. Made over in Taiwan. Multi-core Intel processor, typical reference design type deal. That has to be unscrewed, flipped out of the way. Then you go down and you plug in the new card, but you take off like a card cage, a little top cover and stuff. It's mechanical, but it does take time. It's not going to be a 15-minute ad, just go and you're done. And then you got to tell the radio it's there, just to make sure that you'll enable it in the menu, and then we'll basically I haven't decided whether we're going to put a soft key on the screen or let you just assign it. Well, you're always going to assign it probably to a function key, or like if you guys have K-pods, you could make it even to that to turn it on and off. Yeah.
Why would I want to turn it off?
In my opinion, the audio going through crystal filters is never as good as what we get when we go direct into the DSP and do the filtering there. Well, we can control the filter characteristics, the group delay through it, and a few other fun things to keep it sounding better in that. That's why people like the way the K4 sounds. I mean, you guys know Doug Grant, K1GT? He ran WRTC, I think, when it was in Boston. I think it was. He's back. He was an analog devices guy. He's retired now. But he came up to me at Visalia and actually said this also at the Northeast DX convention outside of Boston this year. I think it was August when I was back there. He got up and basically told me this at Visalia, and I said, hey, if you want to kind of take a quote from you, and I'm going to put it in one of my ads. But he basically said that he only one other receiver he liked the sound as much on as a K4. Because he said the fatigue factor, there's just the ability to pull signals out was so much better than anything he'd used out there. He had an old military radio he liked that was like that. And other people have told me it's like the old 930s, which are getting a little harder to keep working these days. Those were legendary in terms of how they sounded. And this is in that same category, if not
Well,
better.
you said that about your K3.
It's better than the K3. If you put them next to each other, you can definitely hear the difference. K3 is good, but it just all depends what you do with it. And sideband guys tend to notice it a lot more, like in contests or pile-ups, because obviously you're listening to voices and more complex waveform. Though if you have a CW pileup, I guess it can add up to about the same problem there too. But trying to use your ears.
Talk about that, the T.
Yeah. But if you've been on for a contest or been chasing DX all night, you feel it. I mean, I did, especially like low bands for me. That was where I really got it. So having a cleaner receiver is really important. So we worked really hard on it on the K4. So we're getting a lot of feedback from that standpoint. You'll keep hearing that from people because that's been a big deal. So getting back with the HD, it's just like you turn a noise blanker on off. There's always a trade-off, right? Turn a noise blanker on. There's strong signals on the band. They're going to trigger your noise blanker. It's going to start blinking on those. You turn it back off. So you use it when you need to, but there's no free lunch in any of that stuff. So we do as good a job as we can to make it fairly transparent. And a lot of people probably won't even know. So it depends how good your ears are too, right? So and how strong the signals are. Yeah. So most of the time, you're going to have it. You're going to turn it on when you need it. Some people will leave it on though if you're in a contest and you got a neighbor that's just killing you. You're just going to do that, and then you'll be okay. But if you want to get a little bit more of the hi-fi, not hi-fi as in ESSB hi-fi, but low distortion inside the bandpass you're listening to, going directly down into the DSP. Again, it's like the old direct conversion receivers. They sound cleaner because there's less in between doing stuff. Well, you betcha. When you see ripple in a filter, there's a reason that's there, and in terms of both the architecture, but we actually were taking apart the NRAD filters. They don't look any different than the ones we make when you see the individual crystals. Look inside an NRAD sometimes, and they're made by a good company in Japan, and it's exactly the same lattice design. Yes, Russ.
I don't know if you want to tell us, but can you kind of give us a spread of where you get your stuff from, the overseas, what countries?
Oh, well, first of all this, where do we get our stuff from? Wow. Well, if you're buying any passive components these days, resistors, capacitors, inductors, it's coming out of Asia somewhere. I mean, again, it can be a U.S. company. It doesn't matter. I mean, there are cases where, yes, you can get them from a U.S. company. Our wound toroids are done by a company in Texas. They've got, but when you get to high volume, they start having them wound either down in Mexico or offshore. I don't know where they do it. And that's true for most everybody right now. That may change over time, but don't forget our labor rates are, you can either have tariffs or high labor rates. It can get you either way. But we're watching that carefully. Relative to heat sinks, I'm real sensitive to it because especially in the bigger amplifiers, those aren't cheap. These are not, sheet metal is not like $35 or $40 on a radio. Get up into the hundreds. I mean, it's a lot of work there. You have to powder coat it, you got to silk screen it, you've got to do all that stuff.
Are you expect with our new president coming in and is threatening to have tariffs, particularly to the Chinese, that you may have to find a new supplier?
Well, that could affect it. Yeah, absolutely. That really happens. And I always wait and see because we're always in that mode right now where we're running around with hair on fire. We don't know what really is going to happen. But to be honest, before the election and even long before all this talk of tariffs came up, we were already we always do this. We're aggressively looking for alternate vendors that can do the products that are ones that are either material sensitive or offshore sensitive, or just the vendor that we're working with is getting too expensive. They think they have us locked in because they did the extrusion. I paid them for that. Well, if I'm buying enough, I don't care if I paid them a couple $1,000s for another extrusion, and I'll move it to somebody else. So we're in the process of doing that actually in a couple of parts. And actually that happens all the time. I just got a new purchasing agent. She was one of the lead people at Zero Motorcycle, which is now, guess what, offshoring all their production. But she is a killer. I mean, don't if you know her, don't tell her. I tell her she's really good, but she's tough and the nicest person in the world. But she'll smile at you, and get a better deal out of it. But she knows what she's doing. So they're out of Scotts Valley. I think there was somebody here lived in. Yeah, he lived in Scotts Valley. I see them. They're in the old Seagate area where they have their headquarters there. And I had a past life there. Before I did a couple of jobs, a couple of companies before I did Elecraft with Wayne. I was head of engineering for Mountain Computer, PC peripherals company in Scotts Valley. I was the only engineer in 1982. They hired me as part of a turnaround. I was with a company called Source 3. A guy named Bob Hartman was the owner of that, and we were designing early gate arrays before field propaganda gate arrays for LSI Logic, other customers, and I was running that group for that. And but then I wanted to get back into product design. I got recruited in the Mountain, and I ended up doing all their designs and hiring the team. We grew to about 500 people and sold it to Nakamichi late 80s. But which I learned what happens when you sell a company. It's not the same company anymore either. But then went off doing my own things. Did some instrumentation companies and then this ham radio company. So there we are. But anyway, it's a tough problem. I mean, obviously politics can get in the way on that too. I don't know. We'll find out. I mean, my job is to be nimble enough to get ahead of it. So
You don't want to get back to the position you had when we had the pandemic, that's for sure.
no, we don't want to have it where we can't get parts at all. That was the scariest thing in the world. I mean, I own a lot of parts. I mean, good example, we use some parts that I bought so many that were, I'm set for probably life on, and they're discontinued actually. But we have so many of them, and we're not worried about it, you know, that kind of stuff. We can design around it, it just saves time if we don't have to do that and so on. So I have to carry more inventory. That sucks up cash. So that's the nature of the business now. You have to do that a lot more than you used to have to do. But, you know, you dodge and weave, and we got people like yourselves who are pretty tolerant of us as we do that. So it's never easy. So there you go.
I can stop that.
Oh, stop sharing?
Yeah.
Okay, hold on a second here. Let me turn that off.
People can use their cameras if they.
So I can do this with my glasses off. This will be impressive. Let's see. Is that stop? Yeah, it says stop. There I am. I can see myself.
All right.
There I am, guys. Thanks a lot.